Welcome to the AI Checkpoints. Before we get started today, just our standard disclosure. This content is generated by AI. Okay, so today we're diving deep into something pretty significant, a new benchmark called GDPval. The goal here is really to cut through the usual hype and get a clearer picture of how capable AI models actually are on tasks that, well, contribute to the economy. We're basing this on the OpenAI paper GDPval, evaluating AI model performance on real-world economically valuable tasks. Our mission for you, the listener, is to understand where these frontier models really stand today, with solid evidence, before they become, completely widespread.
Exactly. And it's so important because the paper makes a great point. Traditional metrics like AI's contribution to GDP growth, those are lagging indicators. Think about electricity or steam power. It took years, decades even, for their impact to really show up in the economic data. GDPval is trying to be different. It aims to be a leading indicator. It looks at what the models can do right now on valuable work, regardless of how widely adopted they are yet. It's about capability today, predicting future relevance.
Okay, let's unpack that. The scope of GDPval, it sounds massive. We're talking about tasks drawn from the top 9 sectors of the U.S. economy, right? Finance, healthcare, manufacturing.
Professional services, all the big ones.
Covering 44 different occupations tracked by the Bureau of Labor Statistics. And these jobs, collectively, earn something like $3 trillion a year.
That's right, $3 trillion. It gives you a sense of the economic weight behind these tasks.
And the realism is key, you mentioned. These aren't simple academic tests.
Definitely not. These are complex tasks. The paper says they average, 7 hours for an expert human to complete?
7 hours average. Wow.
Yeah, and some tasks took multiple weeks. These are long horizon projects. Plus, they need multimodality. Computer use is essential. Models had to work with CAD files, 3D design files, spreadsheets, videos, audio files, diagrams. Sometimes they had to process up to 38 different reference files for just one task. It's real knowledge work synthesis.
Can you give us a couple of concrete examples just to make it really tangible to people listening? What kind of things were they asked to do?
Sure. So for manufacturing, one task was designing a 3D model of a cable reel stand. Pretty specific, requires technical skill.
Right.
Or, say, for a concierge role, creating a detailed week-long luxury travel itinerary for a family going to the Bahamas. Budgets, activities, logistics, the whole package.
Okay.
And maybe one more like an order clerk task in finance auditing purchase orders to find pricing inconsistencies.
All right.
Requires attention to detail across potentially lots of data.
So definitely not simple Q&A. These are task-producing actual work products.
Exactly. High-stakes deliverables.
Which brings up a big question. How do you even grade something like a 3D model design or a complex itinerary fairly? Let's talk about the evaluation method.
Yeah, the grading was crucial. First off, the tasks themselves were sourced and then validated by real pros. We're talking people with an average of 14 years of experience in their fields. Recruited from places like Apple, Goldman Sachs, Meta, the CDC, big law firms, serious experts.
And they helped refine the tasks too, right?
Yeah. There was this whole iterative process. Each task went through, on average, 5 rounds of review by different experts to make sure it was realistic, challenging, and truly representative of the job.
Okay, so the tasks are solid, then the AI does its thing. How do they judge the output? Model versus human.
The main method was blind head-to-head comparison, pairwise grading, they call it.
Blind, meaning the grader didn't know which output was from the AI and which was from the human expert baseline.
Exactly. An expert in that specific field would look at both deliverables side by side and judge which was better or if they were comparable. And crucially, it wasn't just about, is the answer correct? They looked at everything: structure, style, formatting, even aesthetics. Did it look professional? Was it truly relevant? All those subjective things that matter in real work.
Yeah, makes sense. You need that nuance. I saw they also experimented with an automated grader. How did that go?
They did try that, yeah. It achieved about 65.7% agreement with the human graders, which is, not bad. But the agreement between 2 different human experts evaluating the same thing was higher, around 70.8%.
Oh, okay, so still a gap.
A small gap, about 5%. But it shows that for judging those subtle quality aspects, the human expert's judgment is still, the gold standard for now.
Right. Professional quality isn't easily automated. So after all that rigorous setup and expert judging, what were the headline results? How did the models actually do?
The big finding is pretty striking. The top AI models are getting really close to human expert performance on this set of tasks.
Close how? Like 50-50?
Almost. The best one, which was Claude Opus 4.1, had its outputs rated as better than or equal to the human expert's output in 47.6% of cases.
Wow, nearly half the time. That's significant.
It really is. They're basically at the threshold of parity on these complex, economically valuable tasks.
And is this a sudden jump, or have they been improving steadily?
The paper shows a clear trend, particularly for OpenAI's models leading up to GPT-5. Performance seemed to increase roughly linearly over time.
So a steady climb.
Yeah, the gap between AI and human expert performance has been closing consistently and, frankly, quite quickly.
Interesting. Did they see differences between the top models? Like, were some better at certain things than others?
Definitely. It wasn't a uniform performance. Claude Opus 4.1, the overall leader, really shone when it came to aesthetics.
Aesthetics, like making things look good.
Exactly. Professional document formatting, appealing slide layouts, visual polish. It also handled multimodal files like PDFs and PowerPoints particularly well.
Okay, and what about, say, GPT-5?
GPT-5's strength seemed to be more around accuracy. It was better at strictly following complex instructions and getting calculations right. It excelled on tasks that were more text-based or logic-heavy.
So different models might be better suited for different types of professional tasks. One for visual presentation, another for rigorous accuracy.
That seems to be the implication. Yes, it's not one size fits all.
Which leads directly to the economic side. If these models are near human level, sometimes even better, how does that translate into actual speed or cost savings for businesses using them?
Right. The paper explored that too. They modeled scenarios where an expert uses the AI as an assistant. One scenario they looked at was an expert tries using the model, maybe a few times. If the output isn't good enough after N tries, the expert just fixes it themselves or does it from scratch.
Okay, a realistic workflow.
In that specific setup, using GPT-5 showed potential for about a 1.39x speed improvement. So getting the job done faster.
Nearly 40% faster. That's not trivial.
And the cost improvement was even better, around 1.63x compared to the expert working alone, because AI compute time can be cheaper than expert human time.
Okay, those numbers sound impressive.
Yeah.
There's always a but, isn't there?
Right.
What about the errors, the failure modes?
Yeah. Yes, that's the absolutely critical counterpoint. Human oversight is non-negotiable.
Why? What were the main problems when the models failed?
The number one reason, across all the models tested, for an expert rejecting the AI's work was failure in instruction following.
Instruction following. So not that it couldn't do the task, but that it didn't do it the way it was asked.
Precisely. It might miss a key constraint, ignore a negative requirement, use the wrong format, fail to incorporate specific data from a reference file, things like that.
So attention to detail issues.
Big time. And some models struggled more than others. Gemini and Grok, for instance, sometimes just failed to produce a deliverable at all, or ignored reference data, or used the wrong file type.
In GPT-5, its failures were less severe.
Mostly, yes. About half of GPT-5's failures were graded as acceptable but subpar, usable with significant edits.
But I sense another but.
But about 3% of the model failures across the board were classified as catastrophic.
Catastrophic. What does that mean in this context?
We're talking really bad errors, giving the wrong medical diagnosis advice, recommending fraudulent actions, suggesting things that could cause physical harm.
Oh, wow. Okay, that's terrifying.
It absolutely underscores why you cannot just let these models run unsupervised on high-stakes tasks. That 1.39x speed game looks a lot less attractive when you factor in the need for rigorous human review to catch that 3% risk.
Yeah, the cost of missing one of those catastrophic errors could wipe out any savings instantly. So human review time eats into the speed and cost benefits.
It has to. The oversight is essential.
Okay, so models are capable but flawed, especially on following instructions perfectly. Did the research look at ways to improve performance? To make them follow instructions better?
They did. And interestingly, it wasn't always about needing a fundamentally smarter model.
What do you mean?
Well, first, they found that just telling the model to exert more reasoning effort, sort of think harder, did improve performance for both Claude Opus and GPT-5. That was predictable.
Right.
But the really interesting part was how much simple prompt tuning and better scaffolding helped, giving the model clearer processes to follow.
Like better instructions for the AI.
Exactly. For GPT-5, they tried adding a specific check prompt, basically telling the AI, okay, before you finalize, review your own work, check the layout visually, make sure you haven't used bad formatting, double-check against the instructions.
And did that work?
It made a significant difference. That simple check prompt increased GPT-5's win rate against the human baseline by 5 percentage points, from about 39% to 43%.
Just from adding a self-review step.
Yep. It suggests that a lot of the current errors aren't necessarily a lack of capability, but maybe a lack of, well, internal discipline or process following. Better instructions help unlock performance that's already there.
So better prompting, better process checks could close the gap further.
It seems likely. However, there's another big caveat here related to the tasks themselves.
Oh.
The main GDPval tasks, while complex, were very precisely specified. The models were given pretty much all the context and information they needed right up front.
Okay, like a very clear brief.
Exactly. But real-world work often isn't like that, is it? It's often ambiguous. You have to figure out what information you need, ask clarifying questions.
Right. Managing ambiguity is a huge part of being a professional.
So the researchers ran another experiment. They gave GPT-5 under-specified versions of the tasks, shorter prompts, less context.
How did it?
Performance dropped significantly. It showed that the models, at least currently, really struggle when they have to deal with ambiguity and figure out the necessary context themselves.
That's a major limitation for real-world deployment then, if it needs perfect instructions to perform well.
It's definitely the next big hurdle, the ability to navigate ambiguity, seek clarification, infer context. That's still a very human skill.
And to help push research in that direction, they've open-sourced a lot of this.
Yes, the 220 core tasks and the automated grader code are available publicly. The idea is to let other researchers build on this work.
Okay, so let's try and synthesize this for the listener. What's the main takeaway from the GDPval study? It feels like AI, the frontier models at least, are genuinely capable of performing complex, economically valuable work at a level approaching human experts. The potential is clearly there.
Absolutely. The capability on well-defined tasks is undeniable and impressive.
But this capability is currently fragile. It depends heavily on clear instructions, and it still requires skilled human oversight to catch errors, particularly instruction-following failures and those rare but critical catastrophic mistakes.
That sums it up well. Potential is high, but unsupervised deployment in high-stakes domains seems risky right now. Which leads to, perhaps, a final thought for you, the listener, to mull over. Given that current models struggle so much with ambiguity and figuring out context, things that are absolutely central to human expertise and knowledge work, how do we need to design AI tools differently? How can we better integrate that human ability to ask questions, seek clarity, and navigate messy, underspecified problems with the AI's processing power?
That's a great question. How do we build tools that leverage the best of both human and machine intelligence when the problem isn't perfectly defined? Definitely food for thought. This has been a really insightful deep dive. Thanks for breaking down GDPval with us. Hit like and subscribe if you like the content. See you next time.